Hello there, and welcome. I'm so glad you've drifted in. Maybe your day has stretched long and your thoughts are still circling. Or maybe you're the kind of soul who falls asleep best while wandering through impossible ideas, the kind that twist reality just enough to make it shimmer. However you arrived, you're exactly where you need to be. You don't have to think or move or do. Just let your body sink. Let your breath fall into rhythm, like a tide against the edge of time. Tonight, we're not floating through stars or galaxies. We're slipping into something deeper, the fabric beneath them all. Space-time, the strange, invisible weave that bends, ripples, and carries everything that's ever existed. Scientists can measure it, map it, even watch it ripple, but no one fully understands what it is. So tonight, we'll explore it gently, curiously, like tracing constellations through fog. From warped gravity to time loops, black holes to quantum foam, we'll unravel 100 mind-blowing truths about the universe's hidden stage. Not to master it, but to marvel at it. To drift, one thought at a time, through the quiet pulse of space and time itself. Before Einstein, space and time were thought of as separate things. Space was the stage, vast and still, where the universe performed its endless play. Time was the metronome, ticking evenly no matter who was watching. Everything unfolded within those absolutes, steady, predictable, untouched. Then Einstein arrived, and with one quiet idea, he dissolved the stage and the metronome into a single seamless thing, space-time. It wasn't a background anymore. It was the universe itself, living, dynamic, woven together so tightly that what happened in one thread rippled through all the others. He showed that gravity wasn't a pull, but a bending. Mass and energy told space-time how to curve, and that curvature told everything else how to move. A planet doesn't orbit the sun because of an invisible string tugging on it. It moves along a curve in the fabric. It is falling endlessly through the shape the sun creates, tracing an arc carved not by force, but by geometry. The moon does the same, and so do we. Even the light from distant stars bends as it passes near massive bodies, its path deflected by the very texture of existence. Space-time is elastic. When something massive moves, it doesn't glide silently through a vacuum. It stirs the medium itself. Like a hand running through water, it sends ripples outward, gravitational waves, disturbances that stretch and compress space as they go. For a century, they were only a prediction, too faint to hear, until instruments sensitive enough to detect a distortion smaller than a proton caught one in 2015. Two black holes had merged over 1 billion light-years away, and the waves from their collision passed through Earth, bending space, time, and us. The fabric had spoken, softly, across the void. It's strange to think that even now, as you lie here, you are bending space-time just by existing. Your body has mass, and mass curves the geometry around it. You, me, everyone and everything, tug gently at the structure of the universe. The pull is imperceptible, but it's there. The floor beneath you is slightly closer to the center of the earth than it would be if you weren't there. Every heartbeat, every breath, sends a minute ripple outward through the continuum, vanishing into the quiet stretch of reality. We live not upon the fabric, but within it, part of the weave itself. The deeper you look into this fabric, the stranger it becomes. It can stretch, twist, and even wrap around itself. Around massive stars or black holes, time slows. A clock placed near one will tick more slowly than one far away. The same is true for speed. The faster you move, the slower your time flows compared to those who stand still. It isn't an illusion, it's measurable, repeatable, and real. Astronauts who orbit, Earth age just a tiny bit less than those who remain on the surface. Seconds stretch and shrink depending on the curvature you inhabit. Time is not universal, it is personal. Every being carries its own clock, and no two ever quite agree. Imagine watching a beam of light skim past a star. In the emptiness between galaxies, it travels straight, unwavering. But as it nears the star's mass, its path bends, curving as though drawn by invisible hands. That curve isn't a pull through space, it's space itself curving. Light always moves in straight lines, but in a curved space, a straight line is no longer what we think it is. The universe folds around its own contents, and light simply follows the fold. In the old model, the cosmos was a vast clockwork of forces acting upon objects. In Einstein's version, there are no forces, only shapes. Gravity becomes the poetry of geometry, and the universe a single, self-referential pattern. Space tells matter how to move, matter tells space how to curve. Each is the other's story. You cannot peel them apart. Even emptiness, stripped of stars and dust, still holds the structure curved, responsive, alive with potential. From that revelation came a new kind of beauty. The Earth orbits not because it's being pulled, but because it is falling along a curve in the fabric, perpetually missing the sun. The moon is falling toward us in the same way. And even the photons streaming from your phone's glow are following the subtle dimples carved by the planet beneath you. Everything is motion along invisible paths. Every path is drawn by the weight of what exists. The equations that describe all this are elegant but merciless. They predict black holes, where curvature becomes infinite and time stops entirely. They describe the universe's expansion, not as things moving through space, but as space itself stretching, carrying galaxies apart. They tell us that nothing can outrun light, because to do so would mean outrunning causality itself, tearing the threads that bind events together. These are not metaphors but physical truths. Reality, it turns out, is not built from things but from relationships, distances, durations, the ways matter bends and light travels. If you could see space-time, not as a void but as substance, you'd see it ripple when you move your hand. You'd see your weight depress it slightly, a soft indentation that would spring back as you stood. You'd see planets as whorls in a vast translucent fabric, stars as luminous vortices, black holes as places where the sheet folds inward, vanishing beyond reach. You'd see motion as a consequence of shape, and time as the slope that everything slides down. The revolution Einstein began over a century ago hasn't ended. Every experiment confirms that the fabric is real and pliable, but no one knows what it's made of. Is it continuous, or does it shimmer with hidden granularity at quantum scales? Is it stitched to something deeper still? For now, all we can do is listen to its vibrations and trace the curves it reveals. Space-time is not the backdrop to your story. It is the story. The stage, the actors, the music, the silence between notes, all one fabric, endlessly bending, endlessly telling itself what to be. And somewhere in that vast curved expanse, a small consciousness wonders at the shape of reality and feels faintly the fabric breathing beneath it. If you could drift beyond everything past stars, past galaxies, past even the last stray atom, you might imagine you'd find nothing. A quiet, endless emptiness. But the deeper you go into that supposed void, the more it resists the name. Space is not a hollow stage waiting to be filled. It has texture, curvature, a secret architecture that quietly decides the fate of everything it contains. Even when stripped of matter and light, it keeps its shape. Nothing, it turns out, has form. Einstein's equations revealed that space itself could bend, not metaphorically, not as an optical trick, but physically stretching and warping under the influence of energy. A star, a planet, a galaxy. Each presses its weight into the invisible geometry around it, reshaping the lines along which everything else must move. The universe is not a canvas painted with galaxies. It is a vast, pliant web that bows and swells in response to what it holds. And when the web curves enough, it creates gravity. Matter doesn't cling to other matter. It simply follows the folds of space, as naturally as water running along the contours of a streambed. The shape of space is the shape of destiny. If it bends inward, gravity will eventually pull all things back together. the cosmos collapsing in a final embrace, a big crunch. If it's perfectly flat, expansion may slow but never stop, stars drifting apart forever in a kind of endless dusk. And if it curves outward, if space stretches faster than gravity can pull, the universe will keep expanding into a cold, dark eternity where even atoms drift apart. The geometry decides which story unfolds. In this way, the shape of nothing writes the ending of everything. You can think of this geometry as a kind of cosmic fabric that stretches as the universe expands. The galaxies aren't flying through space like sparks from a fire. They're being carried by the stretching of the space between them. Every second, the distance between clusters grows, not because they're moving, but because the fabric itself is expanding. Even the light that travels through it is stretched as the universe swells, its wavelength pulled longer, its color redder, a silent record of cosmic breathing. And yet, this fabric is not uniform. It ripples, it sags around clusters of galaxies, tightens near black holes, and shudders with the faint echo of ancient sound waves from the universe's birth. These ripples, frozen into the cosmic microwave background, are the fingerprints of geometry itself, tiny variations that grew into everything we see. The grandest arcs of galaxies, the vast filaments that span billions of light years, were seeded by those first trembling patterns in the shape of nothing. Even in the quietest corners of space, curvature lurks. Photons that seem to travel straight across the universe are subtly deflected by the invisible mass between galaxies, their paths bent just enough to tell us the contours of the unseen. Astronomers call it gravitational lensing, but it's really just geometry made visible. Light becomes a tool to trace the curves of the void. Each distortion, each echo, sketches the invisible hand that shapes everything. The human mind struggles to picture this. We imagine bending as something that happens in 3 dimensions, but space-time requires 4. It's not just the shape of space that changes, it's time itself that flows differently through the curved regions. Near massive objects, time slows. Far from them, it speeds up. What looks like emptiness is really a dynamic dance of stretching and twisting dimensions, impossible to feel but always there. If you could somehow step outside of it, you would see the universe not as a cluster of dots scattered through emptiness, but as a single, glowing membrane curved by its own contents. Galaxies like beads on invisible threads, voids like vast hollows in a cosmic sponge, a living map of everything that ever was, suspended in a geometry so subtle it's almost music. The question that remains, one no one has truly answered, is why this shape exists at all. What gives nothing its structure? Why should emptiness obey mathematical laws, bending and stretching as if it were something tangible? Some physicists believe that even the vacuum is filled with quantum fluctuations, virtual particles flickering into and out of existence, giving space a kind of restless undercurrent. Others suspect that geometry itself may emerge from something deeper, a hidden order beyond our equations. But for now, we only know that it is not flat, not lifeless, not truly empty. The shape of nothing is the quiet architect of fate. It cradles galaxies, guides the flow of time, and sets the rhythm of cosmic expansion. It is the invisible hand beneath every falling apple, every orbiting moon, every flicker of starlight. And though we call it nothing, it is the most universal something that has ever existed. As you listen, perhaps you can imagine it, the delicate stretching of a fabric, too vast to see, too slow to feel, but always present. Every breath you take, every second that passes, happens within that geometry. You are part of it, curving space by your presence, held within its gentle slope. And somewhere far beyond, the universe continues to stretch, to breathe, to dream its silent dream of shape. When you drop a pebble into still water, ripples spread outward in widening rings. The surface flexes, then settles, returning to calm as though nothing ever happened. Gravity behaves in a way that feels similar, but the ripples never truly fade. They are etched into the invisible sea we live inside, a vast, 4-dimensional ocean made of space and time. Einstein saw what no one else had noticed. Gravity wasn't a mysterious pull from one object to another. It was the shape of that ocean, bending gently beneath the weight of matter, guiding everything along its curves. For centuries, gravity had been imagined as a force, a kind of invisible tether stretching between the Earth and the Moon, between the Sun and the planets. Newton's equations described it perfectly enough to send rockets to orbit and predict eclipses centuries in advance. But they couldn't explain what it was. How could one body reach across emptiness and tug on another? Einstein's answer was simple and staggering. It doesn't. Nothing reaches across anything. The planet beneath your feet isn't pulling you down. It's curving the fabric of reality, and you are simply moving through that curve. Falling isn't being pulled, it's surrendering to geometry. Imagine standing on a trampoline. When you step onto it, the fabric dips beneath you. Place a heavy ball in the center, and the surface curves deeply, creating a valley. If you then roll a smaller ball across that surface, it will spiral inward, following the slope created by the heavier mass. Not because the big ball is reaching out and pulling it, but because the space around it is bent. This is gravity, not a force, but a shape. Now picture that surface not as a flat sheet, but as the entire three-dimensional space around you. Every star, every planet, every atom creates its own tiny indentation in the cosmic fabric. The more massive the object, the deeper the well it carves. The Earth rests in a gentle hollow created by the sun. The moon circles within Earth's smaller curve, and you, standing on the surface, are sliding ever so slightly toward the center of our planet's indentation, kept in place only by the resistance of the ground. You are not being pulled down, you are being held up. When you jump, your body follows the most natural path through curved space-time, a geodesic, the straightest possible line through a distorted landscape. It feels like falling, but in truth, you are moving effortlessly along the shape the Earth's mass has drawn. The floor interrupts you, pushing you away from the trajectory your body wants to follow. If the planet vanished, you wouldn't suddenly stop being pulled. You'd continue straight along the same curve, unbent, weightless. This idea turns everything inside out. It means gravity is not something acting upon you, but something you are part of. You and the Earth, and every mote of dust in the universe, are participating in a kind of silent choreography written by curvature. The sun bends the geometry around it, and the planets trace their steps within that curve. They are not tethered, they are free, dancing through the fabric, endlessly falling around the sun rather than into it. The deeper this understanding goes, the more astonishing it becomes. Time itself bends along with space. Near something massive, time flows more slowly. Far away, it rushes faster. This isn't just theory, we've measured it. Clocks aboard satellites tick at a slightly different rate than those on the ground. Without correcting for that difference, GPS would fail within hours. The flow of time, the most fundamental rhythm we know, is sculpted by gravity's geometry. It's as though the universe breathes differently, depending on the weight of what lies within it. You might wonder, if everything is curving space, why don't we notice? The answer is scale. The curvature caused by your body, or even the entire Earth, is minuscule compared to the distances between objects. Only in the presence of extremes, black holes, neutron stars, collapsing galaxies, does the bending become so fierce that reality itself seems to fold. There, space becomes so steep that not even light can climb out, trapped forever in the pit it helped to form. Einstein's insight doesn't just describe how things move. It reshapes how we understand existence. The universe is not a stage set for objects to act upon, nor a network of invisible forces straining between points. It is a single, seamless structure whose very geometry dictates motion. Everything moves not because it is told to, but because it cannot do otherwise. Geometry is destiny. When you tilt your head back and gaze at the night sky, you are looking into this curvature made visible. The moon arcs across it, the stars spin along it, and the faint haze of the Milky Way drapes itself across an unseen contour billions of years deep. Each beam of starlight travels along the path laid down by gravity's hand. When that light reaches your eyes, it carries the signature of its journey, the subtle marks of every curve it's crossed, every valley of space-time it has glided through. And yet, for all its elegance, this idea leaves questions hanging like stars we cannot yet reach. What exactly is this fabric that bends? Why should matter curve it, or time respond? The mathematics describe it perfectly, but the essence remains elusive, like a melody whose beauty you can feel but never hold. Still, the truth of it hums quietly beneath everything. The next time you feel yourself falling, whether in body or in thought, remember that you are not being dragged by some invisible hand. You are following the natural curve of the universe, moving through the very shape of being itself. You are not separate from gravity. You are its expression, written in the geometry of space and time. There is a speed woven into the universe that no one can surpass. It isn't simply fast. It is fundamental, a cosmic constant written into the structure of existence itself. That speed is the speed of light. It moves through the vacuum at nearly 300,000 kilometers per second, carrying not only illumination, but information, causality, and the very rhythm by which the universe unfolds. It is the cosmic speed limit, not because of some mechanical barrier, but because reality itself is built around it. Everything that exists, every particle, every clock, every heartbeat is bound by that number, caught in its geometry. Einstein discovered that light speed isn't just a property of photons, it's a property of space and time themselves. When something approaches that limit, the universe reshapes itself to protect it. Time begins to slow, distances stretch, and mass grows heavier. The closer you move toward light speed, the more your reality bends around you. From your own perspective, nothing seems different. You move, breathe, think as always. But from the outside, the rest of the universe slows. Seconds stretch into minutes, minutes into years. Time dilates, like taffy pulled thin across the fabric of motion. This isn't illusion or trickery. It's the deep structure of space-time revealing itself. The faster you move through space, the slower you move through time. Both are part of the same fabric, and when one is strained, the other compensates. The total motion through space-time, your path, your speed through the universe, is always constant. Stand still, and all your motion flows through time. Begin to move, and some of that flow shifts into space. The faster you go, the less remains for time. At light speed, the balance tips completely. Time freezes. From light's point of view, there is no before or after, no distance between emission and arrival. A photon leaving a distant galaxy and striking your eye does so in the same instant. For light, the entire history of the universe collapses into now. It's hard to imagine, because our minds are built for slower realms. We experience the world at walking speed, at heartbeat tempo, where time feels steady and absolute, but the universe plays by different rules. The cosmic speed limit governs everything: matter, energy, gravity, even information. Nothing can outrun light, because doing so would mean outrunning cause and effect. Events would reverse, consequences would precede actions, and the threads of reality would unravel. The universe guards its order by binding us all to that sacred velocity. As we approach it, the costs rise steeply. Accelerating a small particle near light speed demands enormous energy. Each incremental gain requires more than the last. Push harder, and the particle's effective mass grows, dragging against the universe as though reality itself resists. For something with actual mass like you, like a planet, like any speck of matter, the energy needed to reach light speed becomes infinite. It's not simply impossible in practice. It's forbidden by the very definition of space-time. And yet, the consequences of that rule are what make existence coherent. Because light's speed is fixed, it gives the universe its structure. It anchors the relationship between space and time, defining how they stretch and shrink. It determines how far we can see and how long we must wait to know what has happened. When you look at the stars, you're not seeing them as they are, but as they were, their light stretched and slowed across unimaginable distances. The night sky is a living map of time, every point a glimpse into the past. Even the nearest star's glow is a story delayed by years. The deeper you look, the further back you go, until light itself becomes a record of creation. Astronomers sometimes say that when we gaze at distant galaxies, we are seeing fossils made of photons. Each beam carries the memory of a moment long gone, frozen in its endless flight. Some of those beams have traveled for billions of years, crossing the expanding universe to reach us. And though they've journeyed through eons of cosmic history, from their own perspective, they haven't aged a moment. They were born and arrived in the same breath. Light is both messenger and mirror. It moves at the only pace that makes eternity and instant indistinguishable. If you could ride beside it, the universe around you would flatten. Stars ahead would bunch together, their light compressed into a blinding glare. Behind, everything would fade into darkness. Time for you would nearly stop, your heartbeat stretching into infinity, your thoughts suspended in an endless present. The faster you go, the more the universe tilts, until motion and time become two sides of the same truth. This dance between speed and time doesn't just belong to physics. It defines what it means to exist. Every second you live, light is drawing the boundaries of your now. It marks what you can see, what you can touch, and what is still on its way to you. Even here, in this quiet moment, you are surrounded by signals that began their journey long before you were born. Echoes from stars, from galaxies, from the edge of the cosmic dawn, all arriving at the same sacred pace, woven together into a single fabric of cause and effect. The speed of light is the heartbeat of the cosmos, a steady pulse that underlies everything we know. It is not simply motion, it is the architecture of time itself. To move faster would mean to step outside of causality, to escape the very definition of existence. So we live within its boundaries, and in doing so, we are given something profound: order, memory, and meaning. The universe moves through you at the same relentless rhythm, a tide of photons washing against your skin, carrying stories older than Earth. You can't see the speed itself, only the consequence of its constancy, the way it shapes time, the way it gives distance a voice. You exist inside its equation, suspended between seconds and centuries. And in that balance, reality holds together, humming softly at the speed that bends time. If you could place two identical clocks side by side, one in your hand, one aboard a spacecraft, and then send that spacecraft speeding away into the dark, something quiet and extraordinary would happen. Both clocks would keep ticking, gears turning, photons pulsing, each marking the steady rhythm of seconds. But when the ship returned, the clock you held would show more time passed than the one that traveled. The same seconds, measured differently. Nothing malfunctioned, nothing cheated. Time itself had changed its pace. This is the heart of time dilation, one of Einstein's most elegant and unsettling gifts to us. Motion doesn't just move you through space, it changes how you move through time. The faster you travel, the slower time flows for you compared to someone at rest. It isn't a trick of perspective, it's reality bending around motion, the fabric of space and time stretching to keep the universe consistent. Every movement rewrites time just a little, carving its own rhythm into the continuum. For those of us standing still, time feels constant. Seconds come evenly, like footsteps on a familiar path. But in truth, the universe is flexible. The faster something moves, the more it presses against the limits of light, and the more the rules shift. To preserve that ultimate speed limit, time itself must adjust. It stretches and slows for the traveler, keeping cause and effect intact. Motion doesn't steal time, it redistributes it, quietly and precisely, so that every perspective still makes sense. Astronauts who orbit Earth experience this in small, measurable ways. Moving at thousands of kilometers per hour, they live through time just a bit more slowly than we do down here. It's not enough to notice in daily life, just a few milliseconds over months, but it's real. When they return, their bodies have aged ever so slightly less. It's as if the cosmos has granted them a pause, a tiny fraction of stillness carried in motion. To them, time feels normal, steady, unchanged. But from our frame of reference, their journey made time unfold differently. Both are true. Both are real. Imagine the twin paradox, that classic thought experiment. One twin stays on Earth while the other travels near the speed of light. To the traveler, the voyage might last only a few years. But to the one who remained behind, decades could have passed. When they reunite, they are no longer the same age. Not because of some cosmic illusion, but because the geometry of time itself shifted beneath their paths. Each twin lived a full and honest life, each second ticking faithfully. It's only when their paths cross again that the difference becomes clear. Time is not universal, but personal, shaped by motion and gravity like clay. If this seems impossible, consider what time really is. It isn't a separate stream flowing beside us. It's woven into the very structure of the universe. Move through space, and you inevitably move through time. The two are not. Independent, they are coordinates on the same map. When one bends, so does the other. Every journey, from the smallest step to the fastest flight, traces a unique route through that four-dimensional landscape. We all age at slightly different rates, our clocks forever marking the subtleties of our motion. This means that no two people have ever experienced time in exactly the same way. The rotation of the Earth, the gravitational pull of the sun, the faint differences in speed and altitude, all these tiny influences create individualized flows of time. It's happening now, in every breath, every heartbeat. Your seconds and mine are not identical. The difference is too small to matter in daily life, but it's there. A reminder that time is not a universal drumbeat. It's a song that changes tempo depending on where and how you move through the cosmos. The poetry of this lies in its gentleness. Time doesn't break when you move, it flexes. It allows for every perspective to remain self-consistent, no matter how fast or far you go. In this way, relativity isn't chaos, it's balance. The universe doesn't punish motion, it compensates for it, keeping the grand equation harmonious. Light still moves at the same speed for everyone, everywhere, because space and time themselves conspire to make it so. There's a strange comfort in knowing that the faster we chase the future, the slower we experience it. It suggests that motion and time are intertwined in a kind of cosmic empathy. Push harder, and the universe slows you down gently, whispering, "Take your time." Even at the edge of physics, where speed blurs into energy, where seconds stretch into eternity, there's an elegance to the way the rules hold. When you watch a satellite streak across the sky or a jet draw a faint white line at sunset, you are watching clocks diverge time, splitting subtly between the heavens and the ground. The effect is invisible, but it's there in every orbit, every rotation. The stars above you shine with ancient light, their time passing differently from ours, and yet it all fits perfectly together. Every beat, every tick, reconciled across an infinite geometry of motion. If you close your eyes, you can almost feel it. The Earth spins, the planet orbits, the galaxy drifts. You are moving through space at incredible speed, and yet your life unfolds calmly, second by second, heartbeat by heartbeat. You are part of a choreography so vast it erases the illusion of stillness. The clock on your wrist, the pulse in your neck, the rhythm of your days, they are all expressions of your personal trajectory through space-time. You are a traveler, always in motion, carving your own curve through the universe. And with every step, time leans with you, bending to the arc of your journey. Every path rewrites the rhythm of the cosmos, and every heartbeat marks your own private measure of forever. Time does not flow evenly through the universe. It pools and stretches, thickens and thins, responding to the weight of what surrounds it. The stronger the gravity, the slower the rhythm of moments. It's as if time itself feels the pull of mass, hesitating, resisting, lingering in its depths. The same way fog settles into valleys while the mountaintops remain clear, time drifts into gravitational wells and gathers there, reluctant to leave. What we call gravitational time dilation is not some distant abstraction. It's the universe, reminding us that even time has texture. If you place two identical clocks in different places, one here on Earth and one high above in orbit, they would begin to disagree. The one closer to Earth, deep in the planet's gravity, would tick a little slower. The one in space would race ahead ever so slightly, counting fractions of seconds faster. This difference is minute, almost impossible to feel, yet it changes everything. The satellites that guide your phone's GPS must account for it constantly, correcting for the slower passage of time near the ground. Without that adjustment, every direction you received would slowly drift into inaccuracy. The world as we know it depends on this quiet warping of time. The reason is simple but profound. Gravity is not a force pulling downward. It is the curvature of space and time itself. A massive object like Earth bends the geometry around it, creating a slope through which everything moves. Clocks, which are nothing more than devices marking the progression of time, are part of that geometry. When space curves, time curves with it. The deeper you go into the curve toward the center of mass, the slower time passes. The faster you climb away, the more freely time flows. Each height, each distance from gravity's grip, carries its own tempo. On the surface, this might seem like a trick of perspective, but it's not. Time really moves differently depending on where you are. If you were to spend your life at the base of a mountain while your twin lived at its summit, you would age ever so slightly slower. The difference would be too small to matter for lifetimes, but it's there, measurable and real. Gravity doesn't just anchor you to the ground, it pulls at your seconds, reshaping the way they unfold. Every heartbeat, every blink, every moment of thought stretches imperceptibly in the valley of Earth's pull. This effect becomes dramatic, near truly massive objects. A neutron star, dense enough to pack the mass of our sun into a sphere the size of a city, would warp time so severely that an hour spent near its surface could mean days or weeks have passed far away. The gravity there is so intense that light itself bends, curving back toward the surface, reluctant to escape. The deeper the well, the slower the clock. And beyond all measure, at the heart of the cosmos's most mysterious structures, lies the ultimate distortion, the black hole. A black hole isn't merely a massive object, it is gravity, imperfected. It is a place where the curvature of space-time becomes infinite, where the slope grows so steep that even light cannot climb out. To fall toward one is to fall toward the edge of time itself. From a distance, if you watched someone approach the event horizon, the boundary beyond which escape is impossible, you would see their motion slow, their signals would stretch, their light redden, their voice fade. As they neared the edge, time for them would seem to freeze, each instant stretching toward eternity. To them, however, nothing feels strange. They fall as any traveler would, seconds ticking naturally, unaware that to the rest of the universe, they've nearly stopped. This isn't metaphor, it's the universe obeying its geometry. In the presence of immense gravity, time dilates infinitely. The black hole becomes not just a place in space, but a pit in time itself, a frozen surface marking the end of now as we know it. If you could hover safely above it, you could watch entire epochs pass outside while only minutes slipped by for you. Galaxies could age and fade before your next breath. The cosmos beyond would race ahead, leaving you anchored in slow motion at the edge of forever. It's strange to think that gravity and time are so intimately bound. The same force that shapes galaxies and holds the planets in orbit also sculpts the passage of every moment you experience. Every second you live is stretched slightly by the Earth's pull. Every dream and memory delayed by the curvature of the world beneath your feet. Time is not absolute. It bends toward mass the way light bends toward shadow. And in that bending lies something quietly beautiful. Without it, stars could not burn as they do. Their gravity slows time within their cores, allowing fusion to sustain them far longer than it otherwise could. The universe itself owes its longevity to the way gravity slows the ticking of cosmic clocks. Even decay is delayed by curvature, stretched thin across billions of years. Time, it seems, is patient where gravity is strong. When you look up at the night sky, you're seeing moments captured from different tempos. Light from distant galaxies has traveled for eons to reach you, its waves stretched by cosmic expansion, its rhythm slowed by the wells of gravity it passed along the way. You are watching an orchestra of time itself, each star, each cluster, each shadow playing its own measure of the same endless song. Here on Earth, you live within one of its softer notes. The seconds that pass for you are shaped by the mass beneath your feet and the pull of a star 90 million miles away. You may not feel it, but every heartbeat, every breath, is slightly slower than it would be in the emptiness of interstellar space. Time bows gently around you, like fog resting in a valley. You are not separate from it. You are part of its curve, moving through a universe where even the seconds have weight. In the quiet of the universe, there are ripples you cannot see and cannot hear, but they are passing through you even now. They are not made of sound or light, but of space and time themselves, tiny tremors in the fabric of existence. They stretch and squeeze everything they touch, altering distances by less than the width of an atom, then vanishing without a trace. These are gravitational waves, the soft heartbeat of the cosmos, the echoes of immense events so powerful they make the universe ring like a bell. They begin in violence, but travel in silence. When two black holes spiral together, when stars collapse into neutron cores, when galaxies merge in slow cosmic collisions, space-time flexes and quivers. The waves ripple outward in every direction, carrying with them a record of the moment, like the shiver of a drum, still trembling after it's struck. They move not through space, but of it, bending the geometry as they pass, changing the measure of time itself. For a century, they existed only as theory, a whisper from Einstein's equations, predicting that gravity was not static, but alive, capable of motion, of rhythm. It took 100 years, and the most sensitive instruments ever built for us to finally hear that whisper. In 2015, deep in Louisiana and Washington State, twin observatories stood waiting. Each one contained 2 long tunnels, 4 kilometers in length, filled with vacuum and light. Inside, laser beams bounced between mirrors so precise they could detect a shift smaller than the width of a proton. For months they listened, and then, one September morning, space itself stirred. A faint chirp, a vibration too small to move a molecule, appeared on their screens. The instruments had caught the signature of 2 black holes colliding more than 1 billion light-years away. In that instant, energy greater than all the stars in the universe shone for the briefest moment, not as light, but as waves in space-time. We had heard the universe speak for the first time. What those waves revealed was not destruction, but harmony. Space-time, when disturbed, does not break. It sings. Each passing wave is a story told in the language of geometry, a pattern of expansion and contraction that records the shape of its source. One wave may carry the song of merging stars, another, the sigh of a supernova's collapse. If we could hear them directly, they would not sound like thunder but like deep, resonant notes rolling through the cosmic sea, a low, endless hum. Even now, gravitational waves pass through you constantly. They come from faraway galaxies, from collisions so ancient that the light from them will not arrive for eons. They stretch the distance between atoms in your body, between planets in their orbits, though you will never feel it. Space itself breathes, and we are part of that breath. It's easy to imagine the universe as still and vast, but in truth, it's trembling. Every moment, everywhere, the cosmos quivers with faint undulations of its own making. What makes this so haunting is how gentle these waves are. They carry messages of unimaginable violence, black holes devouring one another, neutron stars crushing matter into quantum foam. Yet by the time they reach us, their energy has softened to near silence. A storm becomes a whisper, and still that whisper reshapes everything. In detecting them, humanity gained a new sense, a way to feel the invisible. We once saw the universe only through light. Now we can feel its pulse. Gravitational waves offer a strange kind of intimacy. Light bounces off things. It's reflected, scattered, filtered through dust and gas before it reaches us. But these waves travel through everything, untouched, unaltered, carrying the direct imprint of events long past. They are messages from the deep structure of reality itself, not filtered by matter or energy, but written directly into the fabric of being. When we record them, we are reading the script of creation. Some of the waves we've caught are ancient beyond measure. The first might have been born moments after the Big Bang, when the universe itself was still rippling from its own birth. Those waves still travel outward, carrying the memory of the beginning, the afterglow of existence finding its rhythm. We haven't yet learned to detect them, but they are there, crossing the vastness, threading through galaxies, through atoms, through us. If we could ever listen that deeply, we might hear the first heartbeat of time. There's something profoundly peaceful about knowing this. The universe, for all its chaos, maintains balance. Every crash of black holes, every violent flare, resolves into harmony. The waves fade, but the energy isn't lost. It becomes part of the background hum of everything. It's as though the cosmos hums to itself, softly, endlessly, as it expands. You are inside that music now. Every second of your life, you are being carried on ripples born from collisions far away. You cannot feel them, but they are there, stretching your bones, compressing the air around you, reshaping the distance between your heartbeats. The earth rides those waves like a leaf on a vast ocean, drifting through the soft rhythm of creation. And in that quiet motion, there is a reminder of connection. Every black hole that merges, every star that dies, sends a pulse that passes through you. You are stitched into the same fabric, moved by the same tremors. You don't have to listen to know it's there. The universe is always singing, and somewhere, deep inside that song, is the sound of space and time breathing together in the dark. If you could travel in a straight line forever past every star, through every galaxy, across the silent reaches where light has yet to arrive, would you ever find an edge? Would there be a final border to cross, a cosmic wall beyond which nothing exists? Or would you simply keep moving, looping back eventually to where you began, never realizing you had completed a circle through the curvature of everything? The question sounds simple, but it is one of the oldest and deepest riddles the universe poses. Does space have an edge, or does it fold in on itself like an endless horizon? For most of human history, we imagined boundaries. Ancient sailors feared the world's edge, where the ocean might cascade into nothingness. Even when we learned that Earth was round, we projected that same instinct outward, imagining the heavens as a vast dome enclosing creation. But the cosmos is far stranger than any myth. Space-time is not just big, it is structure without center or boundary, expanding in every direction at once. If you were to set off at unimaginable speed, there would be no edge to crash into, no curtain to pull back. The universe is not like a box you can escape. It is more like the surface of a balloon, curving and stretching, finite yet unbounded. Einstein's equations allow for such a shape, a cosmos that is self-contained, but without edges, a geometry where every direction eventually turns back on itself. It's difficult to picture because our senses are built for smaller worlds. We imagine lines extending outward, but in curved space, straight lines bend naturally, following the fabric's own contour. The shortest distance between 2 points is still a straight line, but that line can wrap around the universe and meet itself again. A traveler moving always forward could return home without ever making a turn. It's not a trick of navigation. It's the architecture of reality. Still, the possibility of infinity lingers. Maybe the universe doesn't close in on itself. Maybe it stretches endlessly, expanding without limit, every point receding from every other as galaxies drift apart. In this case, there is no looping, no return, only an infinite plane of space-time extending in all directions, cold and silent beyond comprehension. From our vantage point, we cannot yet tell which is true. We see only a small region, a cosmic neighborhood lit by ancient starlight. Beyond that, the curvature could fold back upon itself, or it could fade into an infinite beyond. Both shapes fit the data. Both are permitted by the laws of physics. If the universe is curved, it must be curved on a scale so vast that its roundness escapes us. We have measured the cosmic background radiation, the faint afterglow of the Big Bang, and found it nearly uniform, suggesting flatness. Yet, flat, in cosmic terms, doesn't mean truly flat. It means curved so gently that the curve hides beyond the horizon. Imagine standing on the surface of Earth. The ground beneath you feels level. The horizon seems straight. But that's only because the planet's size dwarfs your perspective. Space could be the same way. We live within a geometry too immense to perceive. There are theories that space might be connected in even stranger ways. Some cosmologists suggest the universe could be a kind of cosmic hall of mirrors, where traveling far enough in one direction might bring you back from another angle entirely. The stars you see might not all be unique. Some could be multiple images of the same galaxy, their light looping through space-time to reach us along different paths. If this were true, the universe would be finite yet endlessly repeating, like a song replaying in different keys, each echo a little fainter, a little older. But if the universe is infinite, the implications are equally staggering. Infinity means repetition, inevitability, the endless unfolding of possibility. Somewhere, infinitely far away, another version of you might exist, made of the same atoms arranged in the same pattern, thinking the same thoughts, pausing on the same word at the same moment. And somewhere else, another version diverges, living a different life entirely. Infinity is not just vastness, it is inevitability repeated without end. What does it mean to live inside something with no boundary? Perhaps it means that edges are illusions of perspective. Every horizon we reach only opens to another. Every end we imagine becomes another beginning. In a universe like this, there is no final destination, only endless continuation. The cosmos doesn't have a border to cross. It simply expands into itself. Its limit is not a wall, but time. We are surrounded not by emptiness, but by potential space still stretching, galaxies still drifting, light still finding its way through the fabric. You can think of it as an ocean with no shore, yet one that's always growing. Every second, the space between galaxies increases, not because they are moving through space, but because space itself is swelling, carrying them apart. The horizon, we see the limit of what light has had time to reach us, is not an edge but a boundary of knowledge. Beyond it, the universe continues, unseen, unknowable for now. So if you find yourself staring into the night sky, wondering how far it all goes, remember this: you are not looking outward, but inward, into the shape that contains you. Whether the universe loops back on itself or extends forever, you are part of that shape, stitched into its curvature, carried in its expansion. There may be no edge, no outside, No final frontier, only the infinite continuation of what began long ago. And somewhere, at the limit of what can be seen, space itself is still unfolding, quiet and patient, drawing its own outline against the dark, never reaching an end, never needing one. If you could shrink yourself down smaller than atoms, smaller than protons, smaller than the tiniest particles we can name, you would eventually reach a place where the smoothness of reality begins to dissolve. The familiar order of space and time would break apart into something restless and wild. At that scale so small that our words fail and our equations strain, space-time itself is no longer calm or continuous. It froths, it flickers, it boils like a living sea. Physicists call it the quantum foam, the foundation beneath everything, where existence itself becomes uncertain. From far away, the universe looks steady and elegant. Planets orbit stars, stars gather in galaxies, galaxies drift through an expanding cosmos. Even when you look closer, at molecules or atoms, the patterns still hold. But dive deep enough, and that order begins to unravel. Down at the Planck scale so small that a single centimeter would contain more of these lengths than there are atoms in the observable universe, space and time themselves lose their meaning. They fluctuate, jittering unpredictably, as if reality cannot decide what it wants to be from one instant to the next. It's hard to picture, because everything we know about the world depends on the idea that space and time are smooth. They seem to stretch endlessly, like an invisible fabric. But if you could somehow see the weave up close, you'd find it torn and tangled, full of transient holes, and bubbles that wink into existence and then vanish, almost instantly. These fluctuations aren't noise or imperfection. They are the natural trembling of existence itself. Even the vacuum, which we once thought of as empty, isn't truly empty at all. It's a storm. In this storm, particles and antiparticles pop in and out of being, borrowing energy from nothing and returning it again before the universe notices the debt. They appear, collide, and cancel one another in the blink of a quantum eye. What we think of as emptiness is, in truth, a seething ocean of activity. Every cubic centimeter of nothing contains more raw energy than all the stars in the sky, locked within the invisible fluctuations of the void. Space-time is not a stage on which the universe performs, it's a performer itself, alive with motion. At this level, gravity and quantum mechanics collide, and the rules that work everywhere else no longer apply. Time no longer flows in a single direction. Distance no longer behaves predictably. The very notion of before and after becomes uncertain because space and time are constantly rearranging themselves. What you think of as here and now are temporary agreements between countless microscopic fluctuations. The universe doesn't just exist, it is constantly being remade, every instant, from the chaos beneath. Some physicists imagine the quantum foam as the root of everything. Every particle, every force, every galaxy that will ever form arises from this primordial jitter. The foam may be the mechanism through which space-time itself grows, bubbling outward into expansion, each fluctuation a small creative act. It's possible that black holes and entire universes are born this way, emerging from brief quantum tremors that, by chance, grow instead of fading. Our cosmos could be just one long-lived bubble in a vast, invisible sea of creation. Even though we cannot see it, we feel its effects. The foam leaves fingerprints across the cosmos, in the distribution of galaxies, in the background radiation of the Big Bang, in the flicker of subatomic particles. These tiny tremors influence everything we can observe, like the vibration of strings beneath a song. Without them, there would be no structure at all, no stars, no matter, no us. The uncertainty we find unsettling is also the source of everything stable. The noise is the music. It's strange to think that the universe's foundation isn't solid but restless. We tend to imagine the cosmos as vast and serene, yet beneath its quiet surfaces lies something untamed. The space between atoms in your body is filled with that same quantum storm, the same unending flicker of potential. You are built from it, sustained by it. The solidity you feel is an illusion created by probability and repetition. Beneath it, everything vibrates with possibility. If you could listen closely enough, perhaps you would hear it not as sound, but as a kind of shimmer, a pulse beneath the silence. Every atom humming, every particle flickering, every moment birthing and dying, and being born again. Reality is not a still frame, but a film strip of constant change. And at the smallest scales, the film itself is alive. Somewhere, in the unthinkable depths of that foam, space-time may weave its next layer of complexity, birthing particles, stars, or perhaps another universe entirely. The boundaries between nothing and something blur until they mean the same thing. Creation and destruction are not opposites. Here they are partners in an eternal dance. So when you gaze at the night sky, remember that all of it, the stars, the light, the space between, is floating on a storm you cannot see. Beneath every quiet moment, the fabric of reality is bubbling, trembling, alive. The quantum foam never sleeps. It breathes us into being and swallows us back again, endlessly, like the tide beneath existence. There are places in the universe where the laws of nature go silent, where numbers lose their meaning, where time forgets how to flow, and where the geometry of space twists so violently it can no longer hold its own shape. These are the singularities, the tears in the fabric of reality. They are not merely regions of high density or immense gravity. They are boundaries of knowledge, edges of comprehension, places where the universe itself refuses to be described. A singularity begins as a collapse. Imagine a massive star at the end of its life, its fuel exhausted, its balance gone. For millions of years, it burned brightly, fighting gravity with light. But when the fire dies, nothing is left to resist the pull inward. The core implodes under its own weight. Atoms crushed, particles stripped apart. The collapse accelerates, unstoppable, folding the star into a smaller and smaller volume until the very concept of volume ceases to exist. Density rises without limit. Time stretches, space folds inward, and then silence. The equations that once described everything, gravity, matter, motion, simply fail. There, at the center, the curvature of space-time becomes infinite. We call that place a singularity, but the name hides more than it reveals. It isn't a point in space you could reach or observe. It's a limit, a place where our understanding ends. The fabric of space-time, which behaves like an elastic sheet everywhere else, becomes so distorted that it tears. The thread of causality snaps. Inside that tier, the rules that connect past, present, and future no longer apply. Even light, the messenger of information, can't escape to tell the rest of the universe what happens there. From the outside, the singularity is hidden behind an event horizon, a perfect boundary between the known and the unknowable. In that darkness, time behaves differently. To someone far away, an object falling toward the event horizon seems to slow, its motion frozen by gravitational time dilation. Its light grows redder, fainter, fading into invisibility as though being swallowed by the black. But to the falling object itself, nothing special happens. It crosses the horizon in an instant, continuing its descent toward the singularity at the center. From its own perspective, time moves as it always has. The contradiction is not in the journey, but in our perspective of it, the universe, allowing two truths to coexist, both correct, both irreconcilable. What lies beyond the singularity's surface is one of physics' deepest mysteries. Some believe it represents a true end, a point where space and time are destroyed, where meaning collapses into mathematics that no longer compute. Others suspect it might be a gateway of sorts, a bridge to another region of the universe, or perhaps another universe entirely. The equations of general relativity suggest that, under certain conditions, The fabric could pinch through itself, forming what's known as a wormhole. But quantum mechanics, that restless guardian of the small objects, it insists that infinity is impossible, that space-time must resist total collapse somehow. Between these two pillars of science lies the most profound gap in our understanding. Physicists dream of reconciling them, of finding a theory that unites gravity's smooth curves with quantum's granular dance. Somewhere in that union may lie the answer to what singularities truly are. Maybe they aren't tears at all, but transformations. Maybe the end of one space-time is the beginning of another, the death of a star becoming the birth of something unseen. In the chaos of collapse, perhaps the universe recycles itself, turning destruction into creation in ways we cannot yet fathom. Yet even if we never find that answer, the mystery itself carries a strange beauty. The singularity reminds us that reality, for all its precision, still contains places of wonder beyond reason. It's easy to think of the cosmos as a finished machine, predictable and mapped, but in truth it still hides its heart. Every black hole, every tear in space-time is a whisper from that hidden core, a reminder that knowledge is finite and mystery infinite. The universe keeps some parts of itself secret, perhaps because some truths are too immense for anything inside them to survive knowing. If you could hover safely just outside one of these boundaries, you would see time distort like taffy. The stars behind you would whirl faster, the light ahead would stretch into darkness. The universe itself would appear to bend toward that invisible pit. It would be beautiful and terrifying, the calm surface of space concealing an abyss of pure curvature. And yet, within that abyss, everything that falls is still part of the same whole. Nothing truly vanishes. It merely crosses a threshold where our language can't follow. Perhaps that is the real meaning of a singularity, not an end, but a horizon of understanding, a place where the universe says, this far and no farther, not yet. Beyond this point lies something else, something not meant to be seen through equations alone. When you look up at the night sky, remember that it contains these hidden places, quiet regions where stars have folded themselves into eternity. They are not voids but mysteries, points where existence is pressed so tightly it becomes something beyond imagination. And in their silence, they remind us that even the universe has its secrets, and that sometimes, to grasp the infinite, the fabric must break. If you drop a glass and it shatters, you never see the shards leap back together. You never watch smoke drift back into a candle, or hear a song unplay itself note by note until the air is silent again. Time, at least as we know it, moves in one direction forward, from birth to aging, from sunrise to twilight, from cause to effect. But physics itself doesn't demand that flow. The equations describing the universe work just as well backward as forward. On paper, nothing forbids a broken glass from reassembling. So why doesn't it? Why does time feel like an arrow shot through the heart of everything, never to return? The answer hides in the quiet logic of entropy. Entropy is the measure of disorder, the gradual spreading of energy from concentrated forms into diffuse ones. It's why heat flows from hot to cold, why stars burn their fuel, why ice melts and rivers flow downhill. It's the universe's natural tendency toward balance, a slow, inevitable drift from order to chaos. When you release a glass from your hand, you're allowing energy to spread. The neat arrangement of atoms that made the glass gives way to a scatter of fragments, vibrations, heat. It's not that the reverse is impossible. It's just so improbable that it will never happen on its own. There are infinitely more ways for atoms to be disordered than ordered. Entropy is the tide, and time is the motion of that tide rolling outward. This directionality, this steady unraveling, is what we call the arrow of time. It points from the past, where order once reigned, toward the future, where entropy forever increases. The early universe was astonishingly ordered, a dense, uniform sea of energy. As it expanded, That energy dispersed, forming stars and galaxies, planets and people, all of which continue to burn and cool, to release heat into the growing stillness. The arrow of time is not something separate from the cosmos. It's the pulse of its evolution. It's why we can remember yesterday, but not tomorrow, why ashes don't become trees again, and why our lives unfold like sentences, one word after another, never all at once. Memory itself depends on this asymmetry. To remember, your brain must create structure. It must take a moment, encode it, and store it in patterns of electrical and chemical arrangement. That act increases entropy elsewhere. You burn calories, release heat, consume oxygen. The price of creating order inside your mind is disorder in the world around you. Memory flows in the same direction as entropy, carving your sense of before and after from the universe's ongoing dissolution. In a way, you exist because of time's one-way current, but you also help define it. You are a temporary pocket of order resisting the drift, even as your body slowly gives into it. If the universe were perfectly balanced, if entropy stopped increasing, time would lose its meaning. Events could happen in either direction, or not at all. There would be no distinction between cause and effect, no stories, no motion, no decay. But our universe began far from that balance, in a low entropy state, and it's been climbing toward equilibrium ever since. That climb is what we perceive as the passage of time. It's not that time pushes entropy forward, it's that entropy gives time its shape. The ticking of clocks, the aging of stars, the flicker of thought, all are shadows cast by the same deep movement toward disorder. And yet, there's beauty in that decay. Without the arrow of time, there could be no life, no change, no growth. Stars must die for planets to form. Trees must fall for forests to renew. Every ending gives birth to something new. Even memory, the tender ache of knowing that a moment has passed, is a kind of gift, proof that the universe allows things to happen, to matter. Time's direction isn't cruelty. It's continuity. It's how the cosmos makes meaning out of chaos. There are theories that suggest the arrow of time might one day reverse, that in the far future, as the universe cools toward its final state, another expansion might begin, a cosmic heartbeat, alternating between order and disorder, creation and collapse. If that were true, somewhere unimaginably far ahead, time might run backward, stars unburning, galaxies recoalescing, all of history winding in reverse. But to those within it, the experience would feel the same. The arrow would still seem to move forward, because their memories, their thermodynamic footprints, would be drawn along with it. Perhaps that's the secret. Time isn't a river we float through, it's a pattern we create as we move. It's not so much that time flows forward as that we do, always building, always consuming, always leaving trails of entropy in our wake. Our perception of direction may be the echo of countless small acts of irreversibility. The glass that broke, the breath that warmed the air, the star that burned a little of its fuel. When you think of time, think of it not as a countdown, but as a slow bloom. It's the spreading of potential, the unfolding of all that can be into all that has been. The arrow doesn't pierce you, it carries you, and though it only flies one way, it leaves behind something luminous evidence that the universe once organized itself into the fleeting, impossible miracle of you. Imagine standing at the edge of a vast mountain range at dusk. The peaks stretch endlessly into haze, each one layered behind the next, fading into shades of blue and silver until they disappear in the horizon's blur. From where you stand, the mountains seem to unfold into distance, one behind another, but they are all there at once, unchanging, existing together in a single landscape. Time, some physicists say, may be much the same. We experience it as a journey from one ridge to the next, but the whole terrain already exists, past, present, and future coexisting like mountains under the same sky. Our minds insist on motion. We remember the past, anticipate the future, and live in what we call the present, a moving point that slides forward as if carried by a current. But what if that current is an illusion? What if time does not flow at all? What if it simply is a dimension, not a process? Einstein once described the distinction between past, present, and future as a stubbornly persistent illusion. His equations suggest that time and space are bound together in a four-dimensional fabric, static and eternal. Every moment that has ever happened or will ever happen exists simultaneously within that structure. We don't pass through time, we trace a path through it, like a needle moving through cloth that's already woven. From this perspective, the past isn't gone, and the future isn't waiting to happen. They are both as real as the moment you are in right now. You, sitting here, are just one frame in an infinite film strip that the universe holds all at once. Your childhood, your final day, the first sunrise on Earth, the last cooling ember of a dying star, all coexist within the same grand continuum. We experience them one after another not because they're unfolding, but because consciousness moves through them sequentially. It's our perception that creates the illusion of flow. This idea is known as the block universe, and it challenges everything we feel about being alive. In such a cosmos, change itself is an illusion, each event fixed in its place forever. The universe doesn't evolve, it simply is, a timeless sculpture of space-time. The future doesn't emerge from the past. Both exist eternally, like notes in a chord played all at once. Yet from within, we can hear only one note at a time. Our awareness slides across them, constructing the melody we call experience. It's disorienting to imagine that the moment you're living right now is permanently etched into the structure of reality, unchanging, eternal, as present to the universe as any other. The laughter of someone long gone, the first moment you saw their face, the silence that followed their absence all still exist, somewhere along the dimension of time, as real as this breath. The universe contains all those frames simultaneously. We are the ones who move. If you could step outside of time, you would see everything the full frozen geometry of existence. Galaxies forming, burning, fading, civilizations rising and vanishing. A single heartbeat beginning and ending, both held in the same eternal now. You would see the universe not as a river, but as an entire ocean, every wave existing at once. Our sense of time's passage is just the experience of moving through that ocean, of remembering the peaks and forgetting the ones ahead. And yet, this view raises its own paradox. If all moments exist equally, why do we only ever experience one at a time? What anchors our awareness to the present? Some suggest that consciousness itself creates the illusion of temporal flow, that our minds are wired to interpret experience sequentially because it's how we survive, cause and effect, memory and prediction, all working together to create order in an otherwise timeless reality. Others wonder if the arrow of time is tied to entropy, the universe's slow drift from order to disorder, which gives direction to experience even in a cosmos that may be fundamentally still. But perhaps the truth lies not in choosing one view over the other, but in seeing how they intertwine. To us, time feels real because it shapes everything we do. We love, we lose, we remember. Our stories depend on beginnings and endings, but beneath that narrative, there may be something unchanging, something eternal. The person you were and the person you will become might simply be coordinates on a map that already exists, and your consciousness is the traveler walking its path. Every thought, every emotion, every fleeting instant leaves an imprint that never fades. It's tempting to find comfort in that idea, to imagine that nothing is ever truly lost, that every smile, every sunrise, every heartbeat still lingers somewhere in the vast geometry of existence. But there's a quiet melancholy to it too. If everything is already written, then choice, freedom, even the passage of time itself, may be illusions woven into the fabric of a universe that doesn't move. And yet, even knowing that we live as though time flows because within the illusion it does. Within the illusion we become. Maybe the point isn't to escape the illusion, but to appreciate its beauty, to feel each moment fully, knowing it will always exist somewhere in the tapestry of forever. Perhaps that's what time really is, not a river carrying us forward, but a landscape of eternity we are meant to wander slowly, step by step, savoring the view. The past behind us, the future ahead, and the present a single bright ridge glowing in the sun, our only window into the infinite. Imagine holding a sheet of paper and marking two dots far apart on its surface. To move from one to the other, you could trace a line along the page, traveling the full distance between them, or you could fold the paper so the dots touch, making the journey instant. That's the dream behind wormholes, the idea that the universe's fabric can be bent so completely that distant points meet. These are not doors built into space, but tunnels within it, shortcuts through the geometry of reality itself. If they exist, they would link the far reaches of space and time, as if the cosmos had secret hallways running behind the visible walls of existence. Einstein's general theory of relativity first hinted at the possibility. His equations describe space-time as a flexible fabric, curved by mass and energy. In 1935, working with Nathan Rosen, Einstein discovered that certain solutions to those equations suggested bridges between separate regions of space-time connections we now call Einstein-Rosen bridges. At the time, he didn't believe they were real, just mathematical curiosities. But the idea stuck, and physicists since have wondered, what if the universe actually allows such connections? What if the cosmic fabric can fold upon itself so tightly that two distant stars or two entirely different universes could touch? A wormhole, in theory, is like a tunnel with two mouths and a throat connecting them. One mouth could lie in our galaxy, the other across the universe, or even in a different era of time. The tunnel isn't carved through ordinary space, it's space itself rearranged. Inside, distances collapse. A traveler could, in principle, move from one mouth to the other faster than light could in normal space, not by breaking the cosmic speed limit, but by taking a shorter route through the deeper structure of space-time. It's not faster travel, it's smarter geometry. But the dream comes with a catch. The equations that predict wormholes also predict instability. Under normal circumstances, such tunnels would collapse the instant they formed, closing before anything could pass through. Gravity, the same force that bends space to create the bridge, also crushes it. The throat pinches shut, sealing the connection as quickly as it appears. To hold a wormhole open would require something extraordinary matter with negative energy, an exotic form of mass that repels rather than attracts. We've never seen such material, but quantum theory suggests it might exist in fleeting forms, woven into the restless energy of the vacuum itself. If negative energy could be harnessed, even in tiny amounts, it might stabilize a wormhole long enough for a particle or perhaps a person to pass through. But that possibility opens a new frontier of paradoxes. A traversable wormhole wouldn't just link two places, it could link two times. If one mouth were accelerated near the speed of light or placed in a strong gravitational field, time would pass differently at each end. Step through, and you might emerge not only somewhere else, but someone else. Past and future could become neighbors, folded together like the pages of a book. The line between a shortcut and a time machine blurs. Still, no evidence of wormholes has ever been found. Astronomers have searched the universe for telltale signs: distorted starlight, gravitational lensing, the faint shimmer of something impossible bending space. But so far, the cosmos keeps its secrets. Some suspect that if wormholes do exist, they might be microscopic, smaller than atoms, forming and evaporating within the quantum foam that underlies reality. Others imagine vast cosmic tunnels, ancient relics from the Big Bang, hidden among galaxies like unseen arteries connecting distant corners of the universe. If any of them remain open, they might be the universe's way of folding itself, quietly defying distance. The idea of wormholes captures something deeper than physics. It speaks to our hunger for connection, for finding a way across impossible divides. We dream of shortcuts through time and space, not only because we want to explore, but because we long to reunite. Every wormhole is, in a sense, a metaphor, a yearning for two distant things to touch, for separation to be undone. The equations may be abstract, but their poetry is human. They whisper that maybe the universe itself shares that longing to stay whole, even when it stretches into infinity. If you could travel through one, the experience would defy imagination. The stars outside would blur into strange spirals as light bent and wrapped around the tunnel. Space would feel both endless and immediate, as if every point in the universe were pressing close at once. You wouldn't be moving through the cosmos. You'd be moving through its hidden architecture, the unseen corridors between realities. On the other side, you might step out to find an alien sky, the light of distant galaxies rearranged into new constellations, and though only a moment had passed for you, eons might have unfolded elsewhere. We may never build or find such a passage, but the possibility itself changes how we see the universe. It reminds us that space is not emptiness, it's a living fabric, flexible, mysterious, full of hidden depth. Every fold and curve tells us that the universe is not bound by straight lines we imagine. Somewhere in that vastness, perhaps in the quantum haze between moments, the folds of space might already be touching, silent bridges linking what we think is far apart. And maybe that's the quiet truth of wormholes. Not that they promise escape, but that they reveal how even the cosmos refuses to be entirely separate from itself. Space is always finding ways to meet itself again, bending, folding, reaching inward. The universe, it seems, is stitched together by longing, the same longing that drives us to wonder what lies beyond the next horizon or the next fold of time. When you look up at the night sky, it's tempting to imagine the galaxies racing outward, fleeing from some ancient explosion. You might picture stars shooting through the void, rushing away from one another through empty space. But that isn't what's really happening. The galaxies aren't flying through space. The space between them is growing. The universe is not expanding into something. It's expanding within itself. The very fabric of reality is stretching. The distance is increasing not because of motion, but because the stage beneath everything is swelling. It's as though the cosmos is exhaling endlessly, and every breath carries the galaxies further apart. To understand this, imagine dots drawn on a balloon. When the balloon is inflated, the dots move away from one another, not because they're moving on their own, but because the surface beneath them expands. That's the universe, a flexible fabric whose geometry changes over time. Space-time itself stretches, carrying everything embedded within it along for the ride. The galaxies are passengers, not travelers, floating on a cosmic current that never ceases. No matter which direction you look, every distant cluster of stars appears to be retreating. There's no center of this expansion, no edge, no outside. The universe is not moving outward from a point. Every point is moving away from every other. When scientists first discovered this in the 1,920 seconds, it shattered the idea of a static cosmos. Edwin Hubble's telescope revealed that distant galaxies were redshifted. Their light stretched toward longer wavelengths, a sign they were receding. But the pattern was astonishingly uniform. The farther away a galaxy was, the faster it appeared to move. It wasn't chaos or explosion, it was order. The entire fabric of space-time was expanding evenly, like dough rising with raisins inside. The raisins don't run away from one another. The dough grows between them. Every part of the universe participates in this same silent inflation. What makes this expansion even more mysterious is that it's not slowing down. For most of history, We assumed gravity would eventually halt the stretching, maybe even reverse it, a grand cosmic inhale following the exhale. But in the late 1990 seconds, observations of distant supernovae revealed something extraordinary. The expansion was accelerating. Galaxies weren't just drifting apart, they were being pulled apart faster and faster by something invisible. Whatever this force is, we call it dark energy, a name that hides our ignorance behind simplicity. It's as though the fabric of space-time itself is driven to grow, compelled by an unseen pressure that pushes everything outward. This acceleration has strange consequences. The more the universe expands, the faster distant galaxies move away, until some retreat beyond the reach of light itself. Their signals stretch into infinity, vanishing from our view. The night sky, once full of stars, will slowly grow emptier over cosmic time. Billions of years from now, only our local cluster will remain visible. The rest of the universe will have drifted beyond the cosmic horizon, unreachable, unseeable. The expansion of space doesn't just separate matter, it separates knowledge. Yet even now, in the spaces between atoms, the expansion continues quietly. It's imperceptible on small scales. Bound objects like planets, stars, and galaxies hold together through gravity and electromagnetism. But in the great voids between clusters, the stretching persists. Space itself grows, carrying with it the echo of the Big Bang. But even the phrase Big Bang is misleading. There was no explosion into space. Space itself was what was born. The early universe wasn't a point expanding into emptiness. It was all of space, expanding everywhere at once. Every part of the cosmos began from the same moment, every particle sharing the same origin. The expansion also affects time. As the universe grows, the rhythm of its clock changes. In its earliest moments, everything happened almost instantly. Light, matter, and forces emerging in rapid succession. But as the fabric stretched, that cosmic heartbeat slowed. The seconds we measure now are shaped by that change. Even time, it seems, expands with space, stretching alongside distance, pacing itself with the universe's breath. It's humbling to realize that the stars you see are not racing through emptiness, but floating in a current too vast to comprehend. We tend to think of the universe as a stage upon which events unfold. But it's not passive, it's alive, dynamic, ever-shifting. The galaxies are caught within its pulse, moving because space itself insists on motion, and this motion has no destination. There is no edge the universe is expanding toward, no outside it can reach. It is expanding into itself, making more room for itself as it goes. What this means is that every part of the cosmos is both moving away from something and creating space for something else. It's a balance of separation and birth, of endings and beginnings woven together. Even the emptiness between stars is not static. It's growing, pulling apart the very threads of connection that once tied matter closer. Yet, in that separation, new stars still form, new light still flickers into matter, being. Expansion is not destruction, it's transformation. So the next time you look into the night, remember that the light you see is part of a grand, silent motion that began billions of years ago and still continues, unseen, all around you. Every photon that reaches your eyes has been stretched by the universe's breath, its color shifted by the expansion of everything. The cosmos isn't merely growing, it's becoming. The fabric beneath existence doesn't simply hold the stars. It gives them room to exist, to drift, to shine. And even as it stretches them apart, it binds them to a single truth, that we are all still riding the same wave of creation, carried by the slow, endless expansion of the universe itself. In the distant future, long after the last stars have burned their final light, the universe will begin to fall silent. Galaxies will have drifted so far apart that their light no longer reaches one another. The great structures that once glittered across the cosmic web will dissolve into darkness. their threads of gravity stretched thin by the relentless expansion of space. There will be no dawns or sunsets, no bursts of creation, no warmth left to stir the void. The cosmos will grow quiet not because it ends in fire, but because it runs out of difference. And when every temperature, every motion, every spark evens into stillness, time itself may fade with it. Time, after all, is not an independent current flowing through existence. It's the rhythm born from change, from contrast. The ticking of clocks depends on movement, on decay, on imbalance. Without heat moving from hot to cold, without stars burning their fuel, without entropy increasing, there is no before and after, only sameness. Right now, we live in a universe defined by difference. Bright stars against dark space, energy flowing from concentration to diffusion. But the arrow of time, the sense of forward motion that guides every moment of our lives, is drawn by that gradient. As the universe spreads and cools, that gradient shrinks. When it's gone, time as we know it will have no meaning. The process has already begun. The cosmos expands faster every day, galaxies accelerating away from one another, carried by the invisible pressure of dark energy. Stars die quietly, one by one, their remnants cooling into black dwarfs, dense, cold spheres of ash floating through an ever-thinning void. Eventually, even those embers will fade. The last fusion reactions will sputter out, the last light flicker and vanish. For a while, only the faint glow of decaying matter will remain, but that too will pass. Atoms will dissolve. Black holes will evaporate, releasing their energy in a final whisper of radiation before disappearing completely. What's left will be nothing but thin, diffuse particles and radiation spread across a universe so vast that they rarely collide. At that point, space will no longer have structure. The stars will be gone, and the distances between what remains will be immeasurable. No events will occur because nothing will be capable of change. There will be no more gravity wells to curve space, no more heat to flow, no more entropy to increase meaningfully. The universe will approach thermodynamic equilibrium, the ultimate balance where everything is the same everywhere. This is not a sudden end, but an asymptotic one, a slow dimming stretched across eons beyond imagination. In this endless twilight, the very idea of moment begins to dissolve. For beings like us, time is inseparable from experience. We measure it through heartbeats, through seasons, through the decay of stars. We feel its passage as loss, growth, anticipation. But in a universe where nothing changes, experience itself becomes impossible. If no event distinguishes one instant from another, what does it mean to say time has passed? Without difference, there can be no memory, no future, no rhythm at all. The universe may still exist, but it will no longer happen. Physicists call this the heat death, though the name feels misleading. It isn't destruction, but quiet perfection, entropy completed, equilibrium achieved. It's the universe's most tranquil state, utterly still, devoid of conflict or potential. Every motion that ever was will have come to rest. And in that stillness, time's arrow, the same one that began with the Big Bang, will lie flat. The universe won't end with a bang or a collapse, but with a sigh that never finishes, an eternal pause stretched so wide that even eternity forgets how long it's been. Some speculate that even this may not be the final word. Perhaps quantum fluctuations will persist, tiny ripples in the dark sea of equilibrium, brief sparks of structure arising out of nothingness. Maybe new universes could bloom from that emptiness, like waves reborn from a motionless ocean. In that sense, the death of time in one cosmos could mark the birth of time in another, the endless pulse of being rediscovering itself. But to whatever consciousness exists now, that future will remain forever unreachable, hidden behind horizons that no signal can cross. Still, there's something almost tender in this vision. The same universe that began in fire and chaos will end in calm. the violence of creation, the storms of stars and gravity will all give way to a deep and gentle quiet. Everything that ever lived, every flicker of light, and every thought will have contributed to the gradual smoothing of the cosmos. And though we won't be there to witness it, the story's ending is not tragic, it's inevitable. Time's purpose, it seems, was to bring everything into balance. When you think about the universe's slow fade, it's easy to feel small, but maybe it's the opposite. To exist now, in the brief window between the birth of time and its eventual stillness, is extraordinary. We are the universe in motion, awareness arising from imbalance, consciousness, born from entropy's climb. We live in the heartbeat between expansion and silence. Time flows because we are here to feel it. Someday, it will stop. But in this moment, the moment that still burns with stars, with warmth, with thought, time is alive, moving, breathing. And though the cosmos will one day fall into stillness, the echo of its motion will never truly disappear. It will linger in the memory of existence itself, carried in the stretch of space, in the whisper of everything that ever was. Time may die, but the story it told will already be eternal. There's a quiet strangeness hidden beneath every moment you've ever lived, a shadow world humming beneath the ordinary rhythm of your choices. You turn left instead of right. You speak or you stay silent. You wake or you keep sleeping. And with each decision, reality may divide, not just metaphorically, but literally. Some physicists believe that every possibility that could ever happen does happen, not in some faraway place, but layered invisibly atop this one, woven through the same fabric of space-time. Our universe may not be the whole of existence, but one thread among infinite others, each vibrating with its own version of truth. The idea of parallel realities isn't new, but the way physics whispers it is unsettlingly precise. In the quantum world, the realm of particles smaller than atoms, reality refuses to settle into certainty. Electrons don't orbit neatly like planets. They exist in a haze of probabilities, occupying many states at once until something observes them. When a measurement is made, one outcome appears, and the rest seem to vanish. But where do they go? The many worlds interpretation, proposed by Hugh Everett in 1957, suggests they don't disappear at all. They branch off, forming new universes where each possibility unfolds. Every quantum event is a fork in the cosmic road, and all paths are taken. In one universe, you're reading this sentence. In another, you stopped halfway. In countless more, this story doesn't exist, or you never learned the language it's written in, or the earth itself never formed. Every quantum choice ripples outward, creating entire realities that diverge and multiply beyond comprehension. The multiverse, in this view, isn't a collection of bubbles floating in some higher space. It's the natural consequence of how reality calculates itself. The universe doesn't pick one possibility. It expresses them all, endlessly. At first glance, this sounds absurd. Surely there can't be infinite copies of you, of everything, differing only by a particle's flicker. But in quantum mechanics, the absurd is often what survives. Experiments with photons and electrons show that particles behave as though they travel every possible path simultaneously, interfering with themselves until observation locks them into one trajectory. Everett's idea simply takes that behavior seriously. Each path is real, just inaccessible to us. When you observe the outcome, you're only seeing one branch of a much vaster tree. The others continue, silent and unseen. If the multiverse is real, then the cosmos is not a single fabric, but a tapestry of countless overlapping threads, every one of them connected yet never touching. Each universe would contain its own space, its own time, its own version of you. The total structure would be unimaginably large, perhaps infinite, and yet, in some deep mathematical sense, it might all fit neatly within the equations that already describe our world. Reality would not be a line but a fractal, branching at every moment, forever expanding within itself. And though these other universes might be unreachable, they're not meaningless. Their existence would explain why our world appears so finely tuned for life. The constants of nature, the strength of gravity, the charge of the electron, the expansion rate of the universe seem almost improbably perfect for atoms, stars, and consciousness to form. If there are infinite universes, each with its own variations, then we happen to inhabit one where conditions allow us to ask the question at all. We are the consequence of cosmic statistics, awareness arising where probability permits. In all the others, where gravity crushes too strongly or never binds at all, there is silence. Yet the idea of infinite versions of everything carries a strange ache. If there are universes where your every joy and sorrow plays out differently, then what does it mean to choose? What becomes of responsibility, of meaning, if every path exists somewhere? Maybe the answer lies not in the existence of other versions of you, but in the uniqueness of this one. You experience only this branch, this thread of being. The infinite others do not diminish it. They define its edges, like the unseen darkness that gives shape to light. There are theories that these parallel worlds could occasionally brush against one another, subtle gravitational tremors revealing their presence. Some physicists speculate that mysterious phenomena, dark matter, unexplained cosmic radiation, might be echoes from adjacent realities leaking faintly into ours. If true, then the universe is not isolated but porous, whispering to itself through the walls of dimension. We may be surrounded by other worlds all the time, closer than breath, yet forever out of reach. What's beautiful and haunting about this idea is that it reshapes the notion of existence itself. Every thought, every fluctuation, every possibility becomes real somewhere. The universe doesn't erase potential, it collects it. The cosmos is not a single story but an infinite library, each page turning all at once, every version of you reading a different line. And though you can only live in one of them, perhaps that's enough. This branch, this flicker of awareness, this fragile thread of, now it's one of countless melodies in an endless symphony of being. So maybe when you look up at the night sky, what you're really seeing isn't just stars scattered through space, but reflections of infinite possibilities, each one burning in a universe of its own. You are part of that vast weave, a pattern within patterns, a single note within a boundless song. And even if you can never cross into those other versions of reality, the fact that they might exist at all means something profound, that the universe never chooses one story, it chooses them all and lets every possibility shine. When people imagine the universe expanding, they often picture it like fireworks matter bursting outward from a central explosion, scattering stars and galaxies into empty space. It's a comforting image, easy to hold in the mind, a beginning, a center, a direction. But that picture is wrong. The universe didn't explode into something, it expanded within itself. There is no center from which everything flies away, and no edge where it all ends. Every point in space moves away from every other point equally, like raisins rising in a loaf of bread. The dough expands, but no raisin can claim the role of origin. The universe has no middle, it's all middle. This idea is one of the hardest to grasp because it goes against every instinct we have. We live in a world full of boundaries, rooms have walls, planets have surfaces, oceans have shores. Even our sky has an up and a down. We are creatures built to navigate edges, yet the cosmos offers none. You can travel in any direction forever and never reach a border. There's no outer rim to fall off, no center to circle back to. The universe isn't expanding into emptiness. Space itself is what expands. It grows everywhere at once, evenly, endlessly, without reference to an outside. There is no outside. If you could see the universe from some impossible vantage point outside of space-time itself, you wouldn't witness galaxies racing away from a single explosion. You'd see a four-dimensional shape swelling uniformly, like a balloon's surface growing larger as it's inflated. The galaxies are not flying through space, They are carried apart as space stretches between them. Every observer, wherever they are, would feel as though they stood at the center, watching everything else recede. From Earth, we see galaxies moving away in all directions, and so would any being on any other planet in any other corner of the cosmos. The view looks the same from everywhere. Every point is the center of its own horizon. That lack of a true center isn't emptiness, it's equality. The universe is built so that no place and no moment is privileged over another. The same laws hold everywhere. What happens here happens there, and time flows along its curved, elastic pathways without a master coordinate. Up and down, left and right. These words lose their meaning in curved space-time. Gravity bends them, warps them, reshapes them into something relative. A planet's down is toward its mass. A black hole's down is into infinity. The cosmos doesn't care which way you point, only how the geometry beneath you curves. Einstein showed us that this curvature isn't static. It bends and flexes as mass moves through it. Galaxies form, and with them, wells of warped space where stars and light fall inward. The cosmic web itself, the vast structure of clusters and voids, emerges from these gravitational folds. It's not a rigid frame, but a living fabric, rippling, stretching, breathing. We experience it from the inside, like insects crawling across a balloon, feeling its shape, but never seeing its whole. That's why the notion of a cosmic center feels so natural to us. We keep searching for the place we started from, unaware that the beginning is everywhere at once. When cosmologists trace the universe backward through time, they don't find a location of origin, but a condition. The Big Bang wasn't a point in space, it was a moment in time. Every region of the universe was once compressed, hot, and dense, all of space small enough to fit within what would become every possible coordinate. The expansion began not from a spot, but from a state. When you look deep into the night sky, you're not looking toward the center, you're looking backward in time, seeing the light from when the fabric was younger, tighter, brighter. The farther you look, the closer you get to that shared beginning, not in position but in age. This changes how we think about direction. On Earth, up means away from gravity's pull. In space, there is no universal up. Every motion is relative, every orientation local. The universe isn't built on a cosmic compass, it's more like an ocean, vast and depthless, where every swimmer finds their own horizon. If you drift far enough, the map folds back on itself. Space can curve so strongly that traveling in a straight line might eventually bring you back to where you began, not because you turned, but because geometry itself is circular. The cosmos could be finite yet unbounded, like the surface of a sphere without edges, without an end. It's easy to feel small in a universe like that, to imagine ourselves as lost in something too vast to hold meaning. But the truth is the opposite. If the universe has no center, then everything in it shares the same status. The edge isn't out there, it's everywhere. You are as central to the structure of space-time as any galaxy or star. From your perspective, the cosmos expands around you, stretching its fabric outward in all directions. That's not arrogance, it's symmetry. It means that wherever awareness exists, the universe centers itself again. So when you stand beneath the night sky, remember, you are not looking outward from the edge of something. You are gazing across a shape without boundaries, seeing the same view any being anywhere might see. There is no middle to move toward, no end to reach. You are already at the center, so is everyone else, and everything else. In a universe without edges, there is no preferred point of view. The fabric doesn't expand away from you. It expands with you, carrying you gently through its endless, centerless unfolding. Time travel begins not as fantasy, but as a consequence of physics itself. The equations that govern space-time, Einstein's elegant field equations, do not forbid it. They whisper that, under certain conditions, the universe might allow paths that curve back on themselves, loops in the fabric of reality where cause and effect could meet face to face. In the mathematics of relativity, time is not a river flowing forward. It's a dimension that can, at least in theory, bend, twist, and even circle upon itself. The idea seems impossible only because our minds are wired for straight lines. The cosmos is not obliged to honor that simplicity. Imagine space-time as a great fabric, smooth but flexible. Massive objects like stars and planets bend it, creating wells that curve the motion of light and matter. Now imagine bending that fabric even further, so much that the curve doesn't just dip, but loops back, reconnecting with itself. Such a shape is called a closed time-like curve, a path through space and time that eventually returns to its own past. If you could travel it, you might visit yesterday, shake your own hand, or watch the first light of your own birth. The laws of physics, as written, do not explicitly say no, but they also whisper something unsettling, that the universe abhors contradiction, and it will twist itself to preserve consistency. Relativity already gives us a small taste of time's flexibility. When you move close to the speed of light, time slows for you compared to those who remain still. A traveler who spends a few years on a near light speed journey could return to find centuries passed at home. This is time travel of a kind, not to the past but to the future. It's been proven, measured, and confirmed astronauts aboard the International Space Station age microseconds less than those on Earth. It's a tiny effect, but it's real. Time, it seems, is negotiable. But turning the arrow backward, that's where things begin to tremble. The equations allow it, but the logic resists. One solution, discovered by Kurt Gödel in 1949, described a rotating universe where the entire fabric of space-time twists around itself, making loops possible. Others imagine wormholes, tunnels through the cosmic fabric, where one end could be accelerated or placed in a gravitational field so that its internal clock runs differently from the other. Step through one mouth and emerge not only somewhere else, but someone else. Yet every such idea leads to the same haunting question. If you can go back, what's to stop you from changing what you find? The paradoxes come like shadows trailing the thought. The most famous is simple, the grandfather paradox. If you went back in time and prevented your own ancestor from living, how could you have existed to make the journey? Logic collapses in on itself. One solution, proposed by the physicist Igor Novikov, is the principle of self-consistency. The universe, he argued, forbids contradictions. If time travel is possible, then any event within a time loop must be self-consistent. You might go back, but you could not alter the past in a way that would prevent your own journey. Every action you take becomes part of the history that already was. The timeline is a closed circle, not a line to be rewritten. Another possibility is stranger still. Some interpretations of quantum mechanics suggest that paradoxes might be avoided because time travel creates new universes rather than changing old ones. Each decision, each alteration, splits the world into a new branch. Kill your grandfather in one timeline, and you still exist in another. There is no contradiction, only divergence. Reality, in this view, is endlessly branching, a multiverse where every possible history exists side by side. You could visit the past, but not your past, just a version of it. Even so, the deeper you explore, the more the equations begin to strain. To bend space-time into a loop, you'd need energies beyond imagination, exotic matter with negative mass, densities greater than stars. And as you approach those conditions, the fabric itself may rebel. Quantum effects might shred any attempt at a time machine, creating chaos that seals the loop before it ever forms. Stephen Hawking once called this the chronology protection conjecture, the universe's built-in safeguard against paradox. It seems, he wrote, that the universe does not like time machines and is quite good at preventing them. Yet, something about the idea endures. Perhaps it's because time itself is so intimate, so fundamental to our sense of being. We live it forward but remember it backward, trapped between what was and what will be. The thought of breaking that sequence, of reaching back to touch a lost moment, is both terrifying and tender. To revisit a mistake, to hold a hand one more time, to see the world before it changed. These are human dreams, not equations. Physics only gives them form, wrapping longing in mathematics. And maybe that's the truest paradox of all, that time travel is both forbidden and inevitable. We do it every moment, after all, carried forward by the expanding fabric of space-time, each heartbeat a small leap into the future. The past still exists, written into the geometry of the universe, its light still crossing the dark to reach us. The future already waits, shaped by choices we haven't yet made. We are the travelers, moving along a one-way curve carved by entropy and memory. The loop may never close, but the yearning for it is eternal. Somewhere, deep in the equations, the possibility remains a whisper that space-time might someday allow itself to fold, to let one moment meet another. But even if it never does, we will keep imagining it. Because time is not only what we measure, it's what we ache for. And that ache, perhaps, is how the universe lets us glimpse the loops it hides. There are places in the universe where time itself slows to a crawl, where space folds so steeply that even light cannot climb free. They are not objects in the usual sense, not stars or planets or clouds of gas. They are regions of pure geometry, gravity so extreme it tears the fabric of space-time and reshapes it into something alien. We call them black holes, but that name is misleading. They are not holes in space, but distortions of it, boundaries beyond which the rules we know dissolve. They are the universe's most private places, where matter vanishes and time holds its breath. A black hole begins with collapse. When a massive star burns through the last of its fuel, the outward pressure that once balanced its gravity disappears. The star's core implodes, falling inward with unimaginable force. At first, atoms resist, then electrons and protons fuse, and even neutrons are crushed. The collapse doesn't stop at density, it goes beyond, compressing the mass into a single point of infinite curvature, a singularity. Around that point forms an invisible boundary, known as the event horizon. This horizon is not a surface but a threshold, the dividing line between the knowable and the forbidden. Once something crosses it, light, matter, time, it can never return. To an observer watching from afar, an object falling toward the event horizon appears to slow. Its clock ticks more and more slowly as gravitational time dilation takes hold. Light escaping from its surface grows redder and dimmer until it fades completely. The falling object never seems to cross the horizon. It only lingers at the edge, frozen in time. But to the object itself, the fall is seamless. It crosses the boundary in an instant, unaware that to the rest of the universe it has already been erased. Two realities coexist, one outside, eternal and distant, one inside, collapsing and gone. Inside the horizon, the fabric of space-time twists in on itself. The directions we know, forward, backward, up, down, become meaningless. Space and time trade roles. Moving forward in time becomes moving deeper into the black hole. Every possible path leads inward, toward the singularity at the center, where gravity grows without limit and the equations of physics surrender. The singularity is where general relativity breaks, a place where our understanding of reality ends. No signal escapes from there. No story continues beyond it. It is the universe's unseeable punctuation mark. And yet, black holes are not entirely silent. In the 1,970 seconds, Stephen Hawking discovered that the edges of these voids are not perfectly black. Quantum mechanics, the restless heartbeat of the microscopic world, whispers that even empty space is alive, with particles flickering in and out of existence. Near the event horizon, some of these pairs are torn apart. One falls in, the other escapes. The escaping particle becomes real, stealing energy from the hole itself. Over immense timescales, this process, Hawking radiation, slowly drains the black hole's mass, causing it to shrink, fade, and eventually evaporate. The most voracious things in the cosmos, it turns out, can die of starvation. But this revelation gave rise to a deeper mystery, the information paradox. When something falls into a black hole, all details about it seem lost. Its structure, its quantum state, its history gone. Yet the laws of physics insist that information can never be destroyed. If black holes evaporate completely, where does that information go? Does it vanish into the singularity, defying quantum law? Or does it remain encoded somehow in the event horizon itself, smeared across the surface, like faint writing on the edge of existence? Some physicists now believe the horizon is not a one-way membrane but a cosmic archive. Everything that falls in may leave a trace, a holographic imprint stored in the fluctuations of the surface. If that's true, then the interior of a black hole might be less a graveyard and more a projection, a shadow cast from the information clinging to its border. Reality itself could be holographic, every three-dimensional world an image encoded on a two-dimensional surface. In that sense, black holes may not destroy information at all. They may preserve it in the strangest way imaginable, flattened, encrypted, eternal. What makes black holes so haunting is not just their physics, but their paradoxical beauty. They are regions of total absence that shape everything around them. Entire galaxies spin under their influence, their centers anchored by supermassive black holes and millions of times the mass of the sun. These invisible giants sculpt the cosmos, dictating the rhythm of stars, the formation of worlds, the flow of time itself. Without them, galaxies might never have formed. They are destruction and creation bound together, gravity's final masterpiece. Standing at the edge of one, if you could survive the tidal forces and the silence, you would witness something almost sacred, the moment where time stops behaving like time, where existence folds into mystery. The event horizon is not a wall, but a mirror reflecting the limits of understanding. What lies beyond may never be known, yet the boundary remains, glowing faintly in X-rays and radiation, marking the place where the universe hides its deepest secrets. And perhaps that is why black holes captivate us, not because they represent endings, but because they remind us that endings are never simple. Beyond the horizon, the laws we trust dissolve, but something still persists: information, pattern, maybe even memory. The universe does not throw anything away, it only reshapes it. In the end, black holes are less about absence than transformation. They are the dark hearts of time, where the past falls in, the future waits outside, and reality itself bends to the weight of its own wonder. Imagine waking inside a dream so vivid that you can feel the texture of its air, the pull of its gravity, the heat of a distant sun. Everything seems solid, three-dimensional, undeniably real. But what if all of it, every mountain, every planet, every heartbeat, was a projection, a hologram cast from a distant surface beyond your reach? What if the universe itself works the same way? According to one of the most daring ideas in modern physics, the entire three-dimensional cosmos may be nothing more than a vast illusion of depth, encoded on a two-dimensional boundary far away. You are not moving through space, but through the unfolding of information written on the skin of reality itself. The idea sounds like science fiction, but it grows from the most serious puzzles of theoretical physics. Decades ago, black holes forced scientists to confront a contradiction between relativity and quantum mechanics. When something falls into a black hole, the information that defines it seems to vanish, erased from the universe forever. But quantum theory insists that information cannot be destroyed. Somehow, the black hole must preserve it. The answer came from an unexpected insight. Perhaps the information is stored not inside, but on the surface, encoded on the event horizon itself, the two-dimensional shell surrounding the void. The black hole, then, behaves like a hologram. Its interior is not a separate region, but a projection of the data etched on its boundary. From that revelation grew something even stranger. If this holographic principle applies to black holes, could it also apply to the universe itself? Could our entire cosmos be the inside of a similar projection, its three-dimensional structure, a reflection of data painted across? In some cosmic horizon, the math says yes, or at least it doesn't say no. In the 1990 seconds, physicist Juan Maldacena proposed a model called ADS, divided by CFT correspondence, showing that a world with gravity in 3 dimensions could be fully equivalent to a world without gravity on a 2-dimensional surface. The two are not separate. They are 2 ways of describing the same thing. The universe, in this view, may be a grand correspondence, a reality that looks deep but is fundamentally flat. It's a humbling thought. Everything you perceive as distance or volume might be the unfolding of hidden equations inscribed on a boundary far beyond your sight. The chair beneath you, the sky above you, the atoms in your hand all may be shadows of a higher dimensional code. Even you, with your memories and emotions, might be patterns in that code, shimmering like light on water. If you could step outside the universe and look back, perhaps you would see not a vast expanse of stars and galaxies, but a surface glowing with endless data, each bit representing some facet of the world within. And yet, if the holographic universe is true, it does not make our experience less real. A hologram is not a lie, it is another way of being. The depth you see in a holographic image isn't empty. It's the product of interference, of light waves colliding to create form. Our world, too, may be interference made solid, information vibrating into existence. The illusion of depth could be what gives rise to everything we call real. This theory also whispers something profound about limits. If the universe's information is finite, then even space itself has a maximum capacity for detail. Reality is pixelated at its deepest level, every grain of volume containing a finite amount of data, no smaller than the Planck scale, the tiniest possible unit of length. What looks smooth and continuous from afar is, at the smallest scale, granular, like the dots of ink in a painting that only distance can blend into beauty. You might wonder what this means for consciousness, for the way we perceive time, self, and existence. If reality is information, then perhaps thought and matter are not so different. Your mind could be part of the same code that weaves galaxies, each neuron a flicker of computation in the great cosmic algorithm. The universe might be a kind of self-simulating system, a hologram aware of itself through the consciousness it produces. Every observation you make is the hologram reading its own inscription, reflecting back the patterns that birthed it. There's a strange comfort in that idea. It suggests that nothing is ever truly lost. Information, by the laws of physics, is eternal. It can transform, scatter, and rearrange, but it cannot disappear. Even as stars burn out and galaxies fade, the data of their existence remains written into the structure of space-time. Somewhere, every moment still exists, every heartbeat still echoes in the vast code that defines reality. The hologram remembers, and so the world becomes a kind of miracle, a projection of unimaginable complexity that feels, to those within it, infinite and alive. You are both part of the image and part of the surface it's drawn from, both the reflection and the source. The holographic principle doesn't shrink the universe, it deepens it, suggesting that behind every point of light lies an ocean of meaning. Perhaps that's the secret beauty of this idea. It reminds us that reality is not less mysterious for being made of information, it's more so. The cosmos might not be a vast emptiness we drift through, but a living tapestry of encoded truth, endlessly expressing itself through form, energy, and thought. We are its patterns, its shimmer, its reflection, and though we may never touch the surface where it all begins, We feel its warmth every time we look up into the night sky, each star a pixel in the grandest hologram of all. Every breath you take reshapes the universe, though the movement is too small to notice. Every atom in your body has mass, and mass bends space-time. That means your presence, right now, ever so slightly curves the fabric of reality around you. The floor tilts infinitesimally toward you. Light bends a fraction of a fraction as it passes near your skin, and the air trembles with the subtle distortion of your being. You are not separate from the fabric, you are part of it. Every particle that makes you is a thread woven into the same tapestry as the stars. It's easy to forget this. We're taught to see ourselves as small, as observers looking out into a vast and indifferent cosmos. We imagine that we exist in the universe, like objects floating in a room too large to measure. But that's not quite true. You are not in the universe, you are of it. The atoms that form your bones were once inside ancient stars. The carbon in your cells was fused in stellar furnaces, carried through the void in the ashes of explosions that painted the night with light. The calcium in your teeth, the iron in your blood, the oxygen you breathe, all of it comes from the death of stars. The universe built you out of its own remains. You are not looking at the cosmos. You are the cosmos looking at itself. Every heartbeat sends ripples through the geometry of space-time, tiny waves that spread outward forever. They are unimaginably faint, but they are real, carrying the faint signature of your existence through the fabric that connects everything. The gravitational waves from your steps, your laughter, your quiet moments, they merge with those of planets and galaxies, all adding to the hum of the universe. You are a note in that great vibration, a frequency so small it seems silent, yet essential to the harmony of the whole. Even your thoughts have weight. Each electrical pulse in your brain rearranges the mass energy of the particles within you, and that, too, alters space-time by an immeasurable amount. The curve of reality flexes as you think, as you feel, as you dream. When you close your eyes and imagine something, the universe responds not symbolically, but physically. Its shape adjusts to include that moment. The cosmos doesn't just contain you, it records you. This isn't poetry, it's physics wrapped in wonder. Einstein's equations don't make exceptions for size or scale. They apply as faithfully to galaxies as to atoms, to black holes, and to you. Every speck of mass, every flicker of energy, contributes to the curvature of the whole. That means your life, your body, your thoughts are not trivial distortions in some vast emptiness. They are part of the geometry that holds existence together. Without you, the universe would be ever so slightly different. And yet, you are also what the universe uses to understand itself. Consciousness, whatever it truly is, emerges from matter that became complex enough to ask questions. When you look up at the stars and wonder what they are, the atoms that once were stars are asking about their own past. You are the universe thinking about its own shape, tracing its own edges with awareness. The cosmos spent billions of years forming galaxies, planets, and life just so that one day it could look inward and say, I am. From this perspective, the distance between you and the stars disappears. The light you see from a distant galaxy began its journey long before you were born, yet now it completes its story in your eyes. For that light, you are the destination. When you gaze into it, time and space collapse into a single exchange, the universe sending its memory across billions of years to meet itself in you. The act of seeing is a reunion. It's tempting to believe that meaning must be large to matter, that significance lives in galaxies and ages, not in the flicker of a single human life. But the truth is quieter. The universe doesn't measure importance in size or duration. It measures it in connection. You are as much a part of the cosmic fabric as any star, your existence interwoven with everything that has ever been or will be. The same equations that describe black holes describe the space within you. The same particles that compose the heart of the sun are beating now in your chest, and when you die, those atoms will scatter again, drifting back into the cosmic ocean to take on new forms, dust, clouds, worlds, maybe even new beings that will look up one day and wonder who they are. Nothing is ever truly lost. The universe does not discard its stories. It retells them in new arrangements, new shapes, new songs. You will become part of that song again, as you always were. So when you feel small, remember this. Small things can bend reality. You already do. The fabric of the universe curves gently around you, cradling your existence. You are the sum of stars, the echo of light, the whisper of gravity made conscious. You are not separate from the cosmos, and you never were. You are its awareness, its breath, its heartbeat, its reflection in motion. The universe is vast, yes, but it is not distant. It is here, in you, folding and unfolding with every thought, every breath, every pulse. You are not just part of the fabric. You are the place where the fabric wakes up and realizes it is alive.